So I just want to welcome you to EID, Citizen Workshop. I'm Nancy Holmes. I would like just to introduce our guest speakers here in a sec, and just a little bit of background on the app. This is the launching of the app, the very first time, really, it's being used in a large setting or group. So it's still in its early stages, and there are probably a few little glitches we'll find out about as we move through the outdoor part of this workshop. Its purpose is to help scientists discover, monitor, and learn about bee diversity. Those of you who were at the Elizabeth Ellie's EID workshop last April, when we were doing the beta testing with the paper app, we were looking at pollination activity, right? But that we've sort of switched, the focus of the BID project, so that it's focusing more on what kinds of insects are located near the little patch that you're monitoring, as opposed to the number of visits. So those of you who were at the last BID workshop, you'll notice a little bit of a shift. How many people were at the last BID workshop? So only about 2 or 3. So that's okay. I didn't even say that. Except maybe Kelly. Why an app? These guys are going to talk about that a little bit more, but one of just a really quick reason why we jumped on board as artists and as designers and as supporters of this project is partly because both Emily Carr and UBC are really interested in creating digital tools that can be used by the general public, and we can fund tools that can be used freely by people. And also, we felt that there was a gap, and certainly some of the scientists that we work with on our team have said that there is a gap in the kind of the desire to do citizen science and the quality of the data that citizen scientists transfer to scientists. So the consistency of the data sometimes is uneven. So something like an app, for example, is really convenient for collecting some kinds of data. For example, you may think today is just a gorgeous day, it's really warm and sunny, it's fabulous, so you're going to put on your paper or whatever, gorgeous sunny day, warm, wonderful. Whereas I, being an Okanagan person, I'm going, this is unbelievably freezing. It's cold out there, it's horrible, I can't believe this is May. And so I would write on my paper, cold, right? Because not many of us carry around a thermometer. So what will happen with the app is it will actually just get the temperature. So we can, make sure that data is consistent, and we erase some of the subjectivity of our experience. So that's kind of our motives, right? We have this sort of public, mandate. We also have a lot of art and design experience on the team, and I'll talk a little bit about that. And so we think we can make really good apps, really good looking apps that are attractive and easy to use. And we also wanted to help fill this gap. So I'll introduce our 2 facilitators here today. We have Erin Udal, who's a biologist, and she was formerly of the Environmental Youth Alliance in Vancouver. She has a ton of experience, a wealth of experience in outreach and providing information to people around issues and processes and species, working with young people on many projects. So we're really lucky to have here. I met Erin about a year and a bit at a Pollinator Symposium workshop down in Penticton, and she's always impressed me with her kindness and her generosity in sharing her knowledge. So we're really lucky to have her. And she's been very helpful and instrumental, in fact, of creating the scientific basis of the app. Geoff Campbell is our other facilitator, and he is the designer, technical genius behind all of this. He has a Bachelor of Design from Emily Carr University. He was in his last year at Emily Carr. He was brought onto the Border Free Bees team, and he worked on the prototype of this app for his graduation project. But he also does all our design work. So all this fabulous look of our Border Free Bees stuff is all Geoff's responsibility. I can't tell you how often I get compliments. From all the other digital media people in my university. They go, oh, where's your designer? What a great eye he's got. It's so beautiful. So, yeah, I just, well, yeah. Pays to look down at the car. So Geoff has been just tireless in his devotion to the creation of this app. And I think you'll really find it a beautiful thing to use. So welcome. Thank you so much, Geoff and Erin. And I'll let you take it from here.
Awesome. Thanks, Nancy. Great. Okay, well, I'm just going to jump right into things because we have a lot to get through, and I'm excited to do that with you guys. So if anybody has any questions while I do the first part of this presentation, please just put up your hand and stop me. If I'm needing to keep moving, I'll maybe just ask that we talk about it later, but please feel free to interrupt me. I'm by no means the expert on bees. What I do is I know a lot about bees and I know a lot about people, and that's kind of where I try to overlap my knowledge sharing. Okay, so what we're really talking about today here is pollinator monitoring in an urban landscape. And we're going to start by talking about types of pollinators. This is one of the first start of a pollinator garden that I did about 7 years ago now. Pollinators have really come on the uprise of wanting to be involved in social media and our gardening and in our landscapes, which I think is a really interesting thing. And I've been fascinated how we can combine having wildlife in urban spaces in a more productive way. So we saw butterflies, there's hummingbirds, beetles can be pollinators, bats, and of course, bees. So pollinators are really a kind of special class group of organisms that spread pollen from one plant to another using their bodies. But we're mostly going to focus on bees. The reason for that is that bees are kind of considered the workhorses of the pollination world. They're responsible for about 70% of the world's cross-pollination in plants, and their bodies are completely designed for the service of pollination. And one of the main reasons for that is they're the one group of pollinators that are considered active pollinators. So unlike a butterfly that may land on a flower and just kind of haphazardly get some pollen on it, bees actually put that pollen on their body and increase the efficiency of pollination that way. And that's reflected in our economy. This is from 2013, but bees are responsible in British Columbia for about $366 million worth of our developing resources that we use. And you can see when you jump up to Canada or the US how important they are for our economy. They pollinate about 2/3 of the crops that we use as resources. So some people don't think of things like cotton and flax that we use to also make clothing. And most of the food that we do get from bees is really high in vitamins and nutrients that we wouldn't have available to us otherwise. So bees are really, really important for the things that we get from the world and get to eat. We have them in our greenhouses. In the prairies in Canada, they're important. This is the alfalfa bee on our alfalfa farms. Here in the Okanagan, we use them extensively in our orchards. And in urban spaces, a lot of cities are growing at about 2% a year, and that's definitely not slowing down anytime soon. And if we want to be places where we're having local food security and providing food that is close to us, we're going to have to think about how our urban spaces can also be friendly places for pollinators, because that's not going to exist if we don't have include and think about how to include them in those spaces. And not to make everything about us, bees are also really important to the natural ecosystems that they exist in. So they're considered keystone species, which just kind of means they're the ecological canaries in the coal mine. So if bees are doing well in a certain space, we know that generally other organisms in that area are also probably doing well, just because of how intimately bees are connected to the natural ecosystem, because they're pollinators. Now we're going to talk a little bit more about the groups of bees themselves. There's incredible diversity within the groups of bees. Whenever I see this picture, I kind of think of, if this one here kind of looks like the size of an elephant and this the size of a squirrel or something, but imagine that in mammal form, you'd have something the size of an elephant compared to a squirrel-sized elephant. Just how much niche space and different lifestyles these things must have. And this happens all within one organism. So there's incredible biological diversity within bees themselves. And the first group that we're going to talk about is the honeybee. So the honeybee is a non-native bee. It was brought to North America about 400 years ago, not for their honey, but can anybody guess why? Yes, for wax. We didn't have electricity 400 years ago, and their wax was their primary reason for coming over. The reason I mentioned that they're non-native is because I see, especially in kind of some of our more urban spaces, when people are trying to create community gardens or create community spaces and they want pollinators, they think, oh, well, we'll just bring in honeybees and solve the problem if there's a lack of pollination. And it's really putting a Band-Aid solution onto a kind of bigger issue, that why are our native pollinators not there in the first place? That being said, I love honeybees. Honeybees are awesome as well. I love honey. And they're really fascinating creatures. They are definitely the most social of all the bees. They can, in the summer, a honeybee colony can have up to 50,000 bees in a hive. And they're all talking and communicating to each other. So you can imagine how social they have to be to do that. They have a hierarchy order of keeping everything in check in the hive. This is the queen bee here. She's kind of the head honcho. And then she has all these other worker bees, and they evolve into different roles throughout their lifetime. We could have a whole session today just talking about honeybees, but we're not going to do that. Does anybody have any really specific questions about honeybees that they were burning to get answered today? Yeah?
What's the difference between an Italian and a German in appearance?
In appearance,
Yeah.
They're the same. I mean, there's kind of lighter looking honeybees and darker. Yeah, the ones that we have here would be the same ones we have in Germany, though. They are all Italian honeybees.
Okay.
Yeah. I'm sure that they're slightly genetically different by now in Germany than they are here, but yeah, they're all the same group. Yeah. And they're the only bee that does make honey. Just point that out. And this is kind of what they look like. So this is one of the bees, a common bee that you'll see, and they're kind of the classic bee. So on the app, this is what they look like, what the representative of them looks like, and they have this really classic kind of yellow and black striping. If you ask any 5-year-old to draw a bee, they'll draw you a black and yellow striped drawing. They kind of have a long-ish body, but not as kind of long as some of the other ones that we might see. So I would just say that honeybees are kind of your general common-looking bee. They're kind of a good starting point for learning. And what really distinguishes bees when you guys are out looking at them on flowers is we're going to be looking at where they put their pollen. This is kind of the best way to try to figure out which category they're going to be in. So honeybees put their pollen in what's called a pollen sac. And they have kind of a flatter side of their leg here, and it's in one really specific area. So that's kind of the main thing to look for in the honeybee. The next group of bees is one of my favorites, which is bumblebees. Bumblebees are what I call recycle nesters, so they don't have the ability to make their own nest. They have to use a nest of another organism most of the time. So they'll use old abandoned mouse nests or old abandoned birds' nests, because you can see here, looks like it's probably an old abandoned mouse nest, and there's little bumblebees on the top coming out of it. Heat is really important inside bumblebees' nests, so it's usually useful for them to take over like a small mammal's nest because it's probably already waterproofed and things like that by the mouse. Bumblebees also have a hierarchical order. They definitely aren't as social as the honeybee, though, and live in much smaller colonies than the honeybee can get up to. They also do have a queen, though. You can see her large size, and workers. But they store their honey differently, not in that beautiful hexagonal shape that the honeybee does. Bumblebees store their small storage of honey in what's called honey pots, so these little cups. And then these lighter colored ones here, those are where their larvae would be developing. And bumblebees are important because they can perform a special kind of pollination called buzz pollination. Because of their large size, they can grab onto certain flowers and start vibrating really fast. And does anybody here play a musical instrument? They buzz at the frequency of C, which is, if you hit the note C on the piano, that's the same note. And it's at that frequency that this stigma and anther can pop open to be pollinated. So other bees can't do that. I've seen honeybees try in vain, really unsuccessfully, but bumblebees, because of their large size, can kind of push their way through there and do that job. Bumblebees are the largest, most fuzziest bees. They'll be the first ones you hear and the first ones you see when you go outside. And they also have a pollen basket. So they also have kind of this flat leg and store their pollen on the side there. And this is what they look like on our image. And you'll see on the images, we often put kind of a highlighted area where to look for the pollen. The next group of bees is the hardest group to identify. And we categorize them all into one for ease sake, but there's tons and tons of diversity in this group of bees. These are called the mining bees, and they nest right under our feet. They nest in the ground. These are solitary bees mostly, and they, unlike honeybees and bumblebees, they don't have colonies. They usually, just every adult female is her own queen, and she goes into holes in the ground and provisions her nest. She'll have a lot less offspring than the other kinds. And it often just looks like a tiny little ant hole or something. And as my friend Brian Campbell back in Vancouver often says, if you don't know if you've got bees or ants in your backyard, just pull up a lawn chair and some lemonade and wait to find out. So the mining bees are mostly, they're longer. They're a little bit longer in length, more skinny, and generally most of them that you'll see are probably black. But there are other colors, and some of them have stripes, some of them won't have stripes. But again, the pollen is where it gives them away. And as you can see here, this long, all up and down the legs, we call these pollen pants. So instead of pollen baskets, they have pollen pants. So I always think they look like some sort of medieval jouster or something with pollen all up and down. Yeah?
So I see it's got what looks like hair on its back.
Here?
No, up.
Oh, up here on the thorax, yeah.
So is that because I've
Uh-huh.
And I don't know if it's hair, whatever it is. So is it the only one with that fuzz on the back, or do they all have that?
No, most of them will have it. So if we go back, the bumblebee also has hair. And even the honeybee has hair on their back.
Okay, but it looked like that.
That other one?
Honeybee looks like it has a crew cut, and it was kind of like that. Yeah. Okay, thanks.
Yeah, she kind of does like a crew cut. Yeah. Yeah. Generally, just look for the shape of the body for these ones. The coloration, if they're black, it's probably a good sign that they're a mining bee. And the pollen on the leg is the big one. Yeah.
A friend of mine found nest exactly like that.
Mm.
He said there's a bug fly out, so most likely it's bee. But is there any other bugs that looks like that, like a wasp? So any other? That's one question. Another is if it fly out, does that mean all done, so that he can disturb the area, or should we keep that ground as is?
Yeah, good question. There's also there's tons of species of wasps. Wasps totally get a bad reputation, and we think they're horrible. There's a couple species that are annoying at our barbecues and things like that, but there are a huge amount of wasps that are really, really important to kind of the micro insect ecosystem, and they're kind of keeping control of a lot of the spiders and grasshoppers and things like that. So it could be a wasp flying out, but I still wouldn't disturb it. Wasps are also pollinators, but most likely it is a bee. And sorry, your second question.
If the
Oh, yes.
bugs fly out.
Yeah, if they fly out, no, they're definitely using the nest, and in those holes will be the babies for the next year. So you want to keep that soil there.
For next year.
Yeah, for the next year. So they'll lay the eggs, the babies will, the larvae will be developing underground for the following year, and then they'll come out the next spring. So you want to leave that soil alone. Yeah.
How deep are the ground dwelling? Like, to step on that little tiny anthill looking hole, would you be crushing? Like, I'm always, because you can't verify whether it's full of,
Right.
you know, without digging it up. And so I'm always concerned about stepping and squashing.
I don't think stepping will.
So it's
Well,
quite deep.
No, well, they're anywhere from, I mean, a couple inches to, I think the largest that I've ever heard recorded was 8 feet long, which is ridiculously long. But that's just like a total outlier.
A couple inches.
Couple inches to like a foot. I don't know, what would you say, Lincoln?
Yeah, if you walk on them, probably all right. You know, often they get lost and they can't find their original hole. Or if it rains, they get buried over, so they just have to
Dig them out. Yeah, good question. The next group of bees is called the hairy belly bees. And I'll tell you why in a second. They kind of look like this. They're more kind of rotund than a lot of the other bees. And they nest in horizontal holes in wood, or I've seen them nest in old brick buildings and things like that. And here we have, these are leafcutter bees, so these are all made out of their tube is filled with leaves, and behind these leaves will be their eggs. Here, these are resin bees. So behind here, you can see they've partitioned off their egg chambers with resin, and their larvae are developing. And then this is the one that most people know, which is the mason bee. And it's developed cocoons there, and its larva is developing behind the cocoon. So we have a couple, like I just mentioned, the mason bee. Mason bees, and I don't know if you can really tell from that photo, but they're a little bit more rotund of a bee. They look a little bit more sturdy, and they often get mistaken for flies. They look black, but they're not. They actually have kind of a green shimmer to them, and you can't really see it right here in this image, but you'll get to see some when we actually look at bees. Then we have leafcutter bees. And as you can see, this is what the female is doing. She's cutting out leaves to then go put it in that nest that you guys saw.
She looks a lot like a honeybee.
Yeah, yeah. But the big difference here, and again, it's pollen, that's important. See how the pollen is not on the legs, and she doesn't have a flat leg, kind of like the honeybee. Her pollen is under her hairy belly beak. So that's the big thing to look for if you're not sure with that group. Look at the hairs, and if she doesn't have pollen right then and there on her, it's a little bit trickier, but you can generally still see the longer hairs underneath that the other groups don't have. And she doesn't have that kind of beautiful flat surface like the honeybee does. Yeah, and generally more kind of fat and rotund. Oh, the other thing I was going to point out about bees in general is they have long antennae and they have 2 sets of wings. So a large set and a small set of wings. Because now we're moving on to a hoverfly. So hoverflies are flies that are mimicking being bees. With kids, I call them wannabes. And I think what gives them away is their eyes. If you look here, see how, the image here isn't very good, but the eye is kind of very partitioned here, and if you go here, this is what I call ski goggle eyes. Their eyes go completely across their face. The other important features about flies is they don't have long antennae like bees. They have these very tiny little ones, and they only have 1 set of wings. So when we go outside and try to look for some, because they only have 1 set, their flight pattern is slightly different than honeybees, or than other bees, other pollinators, than bees. So they fly kind of more in a zigzag fashion versus bees. They have 4 wings and they can be a little bit more melodious in their flight pattern, generally.
So what is the benefit to the hoverfly to mimicking a bee?
Good question. Anybody want to take a guess? Yeah.
They're less likely to get eaten if the predator thinks they're going to get stung.
Yeah. It's in your interest if you don't have a stinger to look like something that does. And then the last group that we have here is the wasp. So like I mentioned before, wasps are in this category because they're also pollinators. They're not as good at it, mostly because they're not collecting pollen, and as a result, they don't have very much hair on their body. Some have a little bit, but definitely not like bees. They're not covered in hair. And they're generally have this kind of longer body shape. Their wings, when they're sitting, are kind of these long, skinny things, not because their wings aren't big when they spread out, but they actually tuck them up when they're just resting. So their wings look long and skinny, their bodies look long and skinny, and they, most of the time, will have kind of this black and yellow, bright neon colored striping.
And supermodel waist, little wasp.
Right, yeah, okay. Yeah, good descriptor. Yes, very pinched, narrow waist there. Yeah, so before we go on, we're gonna stop and pull out some bees, and you guys are gonna get to figure them out for yourselves. Okay, number 1. What was number 1?
Shout it out.
Wasp. Any other guesses?
We queried. We weren't sure. It had a waspy waist, but
Well, you're right. Intuition was right. It is a wasp. Woohoo! Right, number 2. Correct. Number 3. Bumble.
What kind of bumble?
Oh, you guys all have different ones.
Oh.
Yeah. 4. Number 5. Yeah, hairy belly, and mason bees are in the hairy belly category. Number 6. Some people had trouble with this one. Number 6. Yes, it's a honeybee. Number 7. Bumblebee, correct. Number 8. Wasp. Number 9. Hoverfly. It has the 2 wings, not 4. Number 10 is a honeybee. So the leg, that flat leg on the side, where they would put the pollen basket, is what you'd look for the honeybee. And number 11.
Mining bee.
Number 11 is a mining bee.
100%.
Nancy's buying around after.
Okay, so you're not out of the woods yet. We have a quick quiz for you now. And we're going to go a little bit quick. And so I want you to jot down your first instinct. You can look quickly at your sheet, but I'm not going to give you very much time. All right, so what was this? Mining bee. This? Correct. This was a kind of a trick. I wouldn't blame you for putting them in 2 different categories. Not a wasp. You might think that it's a hairy belly. It's actually a mining bee. But
You can see how long the abdomen is. It's really stretched out. Hairy belly bee would be more circular.
yeah, look at all that pollen. A carpenter bee? Nope. Hairy belly bee. Well, this one. Look at the legs here. That's pollen pants, all up and down. This one was difficult to see because of the contrast, but it was hairy belly. It's a leaf cutter bee, and the pollen is under there. This one?
Honey.
It's a mining bee, little black bee. This one was tricky. The contrast really made it difficult to see. No. It's a hairy belly bee. Hoverfly. Honeybee. Yeah, this one can kind of tricky because it's got a little bit of hair on it, but it is a wasp. Definitely a wasp. Exactly. Hoverfly. This. Those 2 things the same? This is a honeybee. Look at the eyes on this one. It's a hoverfly. Yeah, this is nice because you can really see the size difference.
What's that flower?
I don't know. It kind of looks like California lilac or something. Yeah, sea holly. Yeah. 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 Now I should just mention, bumblebees are the largest, fuzziest group of bees, but if you see something smaller that's really fuzzy, looks like a bumblebee, bumblebees really range in sizes, especially over the summer. So don't just go for size. If it's a little bit smaller, it can still be a bumblebee. What about these ones? Wasp and a honeybee. I was hoping you all knew what that was. Okay, so we have a quick 5-minute break just to shake your limbs out, and then we're going to get right back to it. So if you want to just kind of stand up, get a quick glass of water, take a bathroom break, go ahead. But we will start in 5 minutes. Okay, so does everybody feel like they know at least a little bit of something more than they knew an hour ago about pollinators? Awesome. So now we're going to talk a little bit more about the context of why are we doing this? Why are we learning about these things? To start us off with that, we're going to talk about the context of being right here in the city. So urban conservation, what are the pros and cons of doing work for bees in a urban space or a city? Well, cities can actually be great places for bees. There was a study done in New York a number of years ago, and with honeybees, and it actually showed that the honeybees produced more honey in the city of New York than they did out in the countryside, which was shocking to people. They didn't think that that would be the result. But one of the reasons for that really is that our rural spaces are looking more and more like this. Big monocrop settings of food, which is a problem because right now this big golden field is all in bloom, but if you're a gardener, you know things are only in bloom for about 2 weeks and then they're done and then the next thing comes up. So if you make your whole crop just one type of plant, there's abundance for 2 weeks and then it's done. So unlike honeybees, where we can bring in those hives for the 2 weeks and then leave, native bees, of course, live right in the ecosystems surrounding them. So this to them actually looks like a desert. This is not a good habitat for native bees. The other thing about agricultural settings is we use lots of these to make sure that our monocrops can survive, which is pesticides. Pesticides are chemicals used to, most of the time, kill insects off of plants. And what are bees? Insects. So it's not surprising that it also affects them as well. Don't like that line there. But cities are also bad places for pesticides too. We don't really think about it as much, but unlike in a rural setting, Health Canada and Agriculture Canada are highly monitoring when and where and how much you can spray. And in a city, until we get better municipal policies in place, anybody can go into Walmart and buy a whole carton load of Roundup or whatever, no offense to Roundup, no offense to Walmart, and use them however they want. There's no regulations. Yeah.
But Roundup's actually an herbicide, though.
Yes, that's true. Sorry, I just used that as an example. And so that is an issue in cities, that we don't have proper regulation and proper use of the chemicals that we sometimes use in our outside spaces.
But
but we should add that when you are spraying your dandelions, you are getting rid of food for bees.
That's another thing. Yeah. Yeah, and we also love this thing. This is the lawn. It is the most highly cultivated crop in North America, more than our food, which is unbelievable to me, but it is. And it's kind of a dead zone for most wildlife as well. Ground nesting bees won't nest in lawn, perfectly manicured lawn like this, and it doesn't provide much habitat. The other thing about cities is there's also lots of this, lots of development. And the more and more development that we put in our urban spaces, of course that limits more and more the space that not just bees, but all sorts of wildlife can utilize. So I'm going to use Vancouver as an example. That's where I've done most of my work. So in Vancouver, we're doing pretty good. There's a goal of it being the greenest city by 2020. And you're within 5 minutes walking distance of any green space at any given time in Vancouver. So it's way better than some of the cities that we have more on the East Coast or cities in Europe, where they've built up places more and more. But like all cities, all green spaces are fragmented. There's nothing connected together. And that's a real problem. Fragmentation is a huge problem in conservation. If this is somewhere down in South America where they've destroyed the rainforest, and you can see here there's this tiny little patch left. The organisms living in this patch don't understand this space in the middle that we've created. There is refuge space over in these other areas, but they don't understand how to leave their patch and how to get to these other spaces. And that is a big issue because if there's a disease that comes through their small patch, they can get wiped out easily. It limits their access to mates, and it limits their access to food. It's the #1 cause of local extirpation events for any type of wildlife. But we have a solution. They're called habitat corridors. This is in Banff National Park, and a corridor was built over the highway, which to us, we understand what a highway is, but to elk, that's a very scary thing, and they're not going to cross it, and they're not going to get back from their breeding grounds over to their eating grounds if we don't make things like this. So corridors are really, really impactful and important to wildlife. So then back to a city context. What does that mean in a city? Well, if all our green spaces, which are kind of our refuge spots, are isolated, we need to make ways of connecting them. So right now, what you're looking at, this is Van Dusen Gardens in Vancouver, and that's Queen Elizabeth Park, 2 of our largest parks in the middle of the city, but they're fragmented. So what we have done, and this goes with the corridor concept, is you can make what I call habitat islands. So we're not going to rip up entire city blocks in our urban spaces and give them back to nature. Try going asking a politician to do that. It's not going to happen. But what we can do is create kind of these jumping spots. So a bee would not be able to fly this distance, but it might be able to fly that distance. And then the next year it might be able to fly this distance and this and this and this. And create more integrity for the green spaces that we have left to support our wildlife. So that brings us to here. So you also have green spaces and spots that could do better. So this is what the Nectar Trail is all about. It's building habitat corridor across Kelowna so that we can provide more habitat for the pollinators. And I would say that the biggest thing that I've learned about in cities isn't even fragmentation or habitat loss or pesticides. It's our perception of them. My biggest job is changing people's minds about bees. Bees and people have been had a very long history together. We've been keeping bees since the time of the Egyptians, and they're in most folklore all over the world. Today is a little bit different, We have a very kind of intricate relationship with bees, and we tell all kinds of strange stories about them. They're in our superheroes, in our artwork, in our horror films. We've even infected our hairstyles. And I would say even from a very early age, we've developed a narrative and a story about what bees are in relationship to us. And the media in the last 10 years, with everything that's happened with bees, has had a definite impact.
Why are the province's bees dropping like flies? We'll smoke out a few answers for you tonight. Your news first. CBC News Winnipeg starts at 5.
Oh.
Bees are mysteriously dying.
It's called colony collapse disorder. Beekeepers in 27 states report disappearing honeybees.
Pollination by bees produces 30% of our food.
Congress is holding hearings. Even the vice president has been briefed.
A storm is gathering on the horizon. An invasion, decades in the making, is underway. An alien species is staking claim to the Americas. Creatures that will die rather than retreat. And by the time you see that, a fight may already be lost. Incredibly, they're the result of a single experiment. An experiment that went terribly wrong. An experiment that gave us the killer bee.
A third of the food we eat depends on bees for pollination, but the honeybees are disappearing fast. We need to save them, because without the honeybees, the fruits, the vegetables, and the flowers that depend on...
Okay, so lots of mixed messages there. You know, everything from colony collapse disorder, the bees are dying, to killer bees, they're gonna, you know, come here and ravage us. So we're going from anywhere on the spectrum, from these scary, misunderstood organisms to that they're these cute and fuzzy things that we want to save and just like warm up to. And in reality, bees are neither of those things. They're living, breathing organisms, and they're somewhere in between that spectrum. And that's what citizen science is all about, is not being on either end of this spectrum. Talking about the narratives is actually giving you a real experience and developing that relationship for yourself, again, with bees. How do I get out of this?
We're going to mine now.
Yes. Or no, the citizen science.
Oh,
Other
it's on a
one.
different presentation.
That one. Oh. That one. So that brings us to pollinator citizen science. Sorry for the delay. Okay, so why are we doing this project? Like Nancy mentioned at the beginning, there's lots of bonuses to having many eyes out there collecting information. So the scale of observations can be accessible to all. Science isn't something that's hidden up in an ivory tower. All of you can access it. This is a really unique moment to study pollinators. We're really missing a lot of information, especially for the native species, about what's out there. So you're actually making a difference. You're actually contributing to what's happening, and especially what's happening in our urban spaces, because we don't really understand how cities impact our pollinators. And then we're building a human connection to these organisms. And I always find that learning more about them leads to understanding more about them and having more acceptance of them. So what is citizen science? Citizen science is when citizens actively contribute to science either with their intellectual effort or surrounding knowledge or with their tools and resources. I'd say that you guys are going to do all those things. So this is our goals in the project. We're going to collect large-scale data, increase public awareness, and get valid scientific outcomes. So last year at Van Dusen Gardens, we actually found out what kinds of bees are existing there. The highest proportion was actually flies. But this is the kind of thing that having people out there collecting data in certain areas will give us. So how do we ensure quality and how do we ensure participation? Well, with the app, we're making repeatable, simple tasks. Mostly everyone these days has a cell phone, and your information is literally just a click away. Hopefully we're giving you appropriate training and ongoing support. So when you submit photos, there's someone on the other end checking those photos and having a dialogue about what those are. And we're also, as Nancy mentioned at the beginning, limiting the necessity of skill level. What we want you to do is take a photo and take your best guess at what that is. We have that information then stored in a photograph of what you saw. So we're not miscalculating if it's a nice day or a poor day. We have the temperature right there. And so now Geoff is going to show you all the beautiful ways to do that.
All right, so hopefully that gave you a sense of what the app's all about. So this whole project started about 1.5 years ago when Dr. Cameron Cartier, who's the lead in Vancouver for the Border Free Bees project, she proposed this idea to me, and I was going into my last year at Emily Carr University and ended up making it my thesis project. So our goals with the app were to improve the quality of citizen science data, to hold education sessions and teach people about pollinator ecology and identification, and to encourage people to just get closer to nature and develop an appreciation for how amazing these little creatures are. And we also saw an opportunity to use the app. Yes, we have someone in the audience featured in the photo here, just realized. So we saw an opportunity to use the app in the pollinator pastures that we've developed in Richmond and here in Kelowna to test the quality of these spaces to see how they affect the diversity and abundance of the different pollinators. Here's us with another group. We spoke at a conference at Science World, and this is us on the roof of Science World in their garden, testing the methodology before the app was developed. And we held some BID training workshops in the Lower Mainland with a bunch of youth groups, and there was an opportunity in that to get feedback throughout the design process of the app to really make sure it would be accessible and user-friendly and so forth. So that was really important part of the process for us. We partnered with the Pollination Ecology Lab at Simon Fraser University. That's run by Dr. Elizabeth Ellie, and she was really, really helpful in the process of developing the methodology that we used in the app for making an observation. And she helped us to determine the categories that we use in the app because, of course, there's hundreds of species of pollinators just here in BC. So we needed to simplify that and create these categories. So we wanted to have enough categories that it would actually lead to useful information for scientists, but we didn't want it to be too complicated, so we found a happy medium with these 7 groups that you've learned about today. And the illustrations I developed over some time, we wanted them to be not too simple and playful like a cartoon drawing, but also not too realistic like a photograph, because the images represent multiple species, so we didn't. So we want to strike a balance in the middle. So the main things that the app offers is a platform for recording your observations. There's educational tools, kind of like what you're seeing on the cheat sheets there, which you can access while you're making your observation. And there's a section where you can explore the data that you've collected yourself, as well as all the other people who are contributing. Pretty soon, we're going to be launching this Facebook page, which will act as a forum for online discussion. So if you have a question about pollinators, or you have a photo of a pollinator or a flower you're trying to identify, you could submit that on Facebook. And Dr. Elizabeth Ellie and her grad students at SFU are going to be on the back end of that, helping to answer your questions, because they're the true experts. Yes?
People who aren't on Facebook can still access that?
You can access it and view the page, but you won't be able to ask questions. We decided to do it on Facebook because it's a great way to engage with people, to encourage people to participate. And it's the social network that kind of spans the gamut of all the different types of people. So yeah, unfortunately, if you don't have Facebook, you can't fully participate in this. So some of the main reasons why we decided to go with an app. So it simplifies the process of making an observation. Like Nancy mentioned earlier, it'll automatically collect information like the current weather conditions, the date and time, and other pertinent information to the scientific research. So therefore, it improves the consistency and the quality of the data, so it's more useful to scientists. And the methodology that we developed is universal to North America. So wherever you are in North America, you can pull out your phone, spend 5 minutes making an observation. And it's just very accessible. So if you're walking to the grocery store or running errands or anything, and you have your phone on you and you happen to stumble upon some flowering plants, you can spend 5 minutes making an observation. So you don't have to be locked into a program or anything. You can just do it on your own time. Does anyone have any questions at this point? Yes?
If my phone's GPS is on, would it track the location with the GPS?
Yeah. Yeah, you have to accept that the app will track your location in order for that to work. Yeah.
So it is actually an app?
Well, it runs in the browser right now. This is still kind of the beta app. Next year, we're going to be developing a native app that also won't require an internet connection while you're making an observation, which is a really big thing that some people aren't able to participate because of that. So right now, if you don't have Wi-Fi where you are, you're going to have to use your data to make an observation.
Well, thank you so much, Erin and Geoff. It was really terrific presentation. Really helpful. Love the test, the quizzes.
That's the best part.
Yeah, test is the best, yeah. So thank you so much.